linear regression, which is the model that I'm using, is something that I picked up on my own. On Jason Brownlee's site, he used another type of regression technique, or he used time series analysis. But I was reading that you can use regression to solve time series, linear regression, to solve time series analysis. So I wanted to do that. And the reason why I wanted to do that is because one time I was reading an article about a blog post that this person had written, and her friend had gone to a college class, and the instructor said he wanted that person to do a time series analysis using only pandas, NumPy, and sklearn. So the linear regression is in sklearn, but you can also write your own linear regression from scratch if you want to. This is something I haven't quite gotten around to yet, but I thought, well, it's going to be a good idea. And I researched it on Quora website, and on the Quora website they said that you can use linear regression for time series analysis. So I thought, well, that will be a good thing for me to do, is to use linear regression for time series analysis and see what we get. So that's what we're going to do. We're going to do time series analysis using linear regression and see how far we get on this. And then I also plan on using FB Profit and stat models, and then we can compare the results that we get with linear regression, FB Profit, and stat models. Unfortunately, I cannot use Jason Brownlee's work because he had a different methodology to come up with time series analysis. But we'll go ahead and use the linear regression since that's what I personally came up with. So we've got our program that we've written. We've written the program in Google Colab. Google Colab is a free online Jupyter notebook. In fact, on my Chromebook, this is when I first started learning Python, I had installed Linux onto my Chromebook, and I had installed Python and a bunch of libraries and stuff onto my Chromebook. But then I found out I could use Google Colab, and then when I started using Google Colab, I just never looked back from that. So on my new laptop, which I had to get because my Chromebook malfunctioned, and I won't be getting another Chromebook, by the way, I did not even install Linux or Python or anything like that onto my new laptop. I'm just using Google Colab specifically because that way I don't have to worry about installing any software and installing any updates. So after I created the program, then what I wanted to do is I wanted to import my libraries. A good thing about Google Colab is because the libraries are already installed, all you have to do is import them. So I imported Pandas and Matplotlib. I didn't import any NumPy at this time. So we read in our data set. This is a data set that I got from Jason Brownlee's site. And the thing I'll say about Jason Brownlee is he loves functions. He absolutely adores functions. Almost everything is a function. But I'm not really a function person myself. But there is a function in here. It's a lambda function. Because lambda is a function that you can make so you can define your own, a really small function. And so that's what I did. So we imported this data set from Jason Brownlee's site. Series equals reads underscore CSV. Then the CSV file, header equals 0, parse dates equals 0, squeeze equals true, date parser equals parser, and then the index column, I said that equals 0. If you wanted the index column, then that would affect the reading for linear regression. It was okay for the methodology that Jason Brownlee was using, but he wasn't using linear regression. So I had to delete this index call equals 0 so I can get the data set to work the way that I wanted it to work. So now we've got series. In series, you've got the month and the cells, and you can see that this is a very old data set. It was designed in 1901, so this data set is about 120 years old, and it talks about sales of shampoo. And so we've got actually 36 months where they collected this information. So we check the info on the data set. So the month is date time 64 NS, and the sales is a float 64. We check for any null values. We do not have any null values that need to be imputed, so that's good. So now what we do is we ordinal encode the date, and this is where we put our lambda function in there. So series date underscore ordinal equals series month dot apply lambda x dot to ordinal series. So what we've done is we've got like a really tiny function where we have ordinal encoded the month. So now we've created an extra column called date ordinal. And there is also in date time, I think in date time there is a function where you can convert something to numeric data as well. And I think that's in the date time library, but we're just using the pandas library in this instance. And the thing about Python is they have lots of different ways that you can do things depending upon which library you're using. So you can do things in pandas, but you can also do things in sklearn. So it depends on what library you're in as to whether or how you're going to go about doing it. So in this instance, we were in pandas, so we just used the toOrdinal command for pandas. So now we don't need the month anymore because this is going to be used as a time series. And since we don't need the month anymore, then we just drop the month. So now we just have a sales column and a toOrdinal column. Okay, so now what I've done is I've graphed a plot of the sales. So you can see the plot graph of the sales here. Okay, now so what we've done is we split our data set up into training and validation. And again, we didn't use sklearn to do this. This was done just from the pandas library, because you notice we're not even using any NumPy in this particular example. It's just pandas. So this is the code that I used to split my data set up for training and validation. And then so we checked the shape of it. So we had X train, Y train is 31, and X val, Y val is 4. But in order to get linear regression to work, you had to reshape it. So X train equals X train dot reshape, -1, 1. X val equals X val dot reshape, -1, 1. And then so we check the shape on that. And so the shape for X train and X val is what linear regression wants to see in order to do its work. And I'll tell you another thing that I did was in the linear regression function, you have the facility to be able to normalize the data. Okay, and so when you normalize the data, you don't need to standardize. So I had originally put a standard scaler in there with sklearn, but when I saw there was a code in linear regression to normalize it, I put normalize to true, and then I just deleted the cell where we were talking about standard scaler because you didn't need the standard scaler since it was normalized. So now what we do is we define our model. We use linear regression from sklearn, but if you had wanted to, you could have design linear regression first from scratch, which I haven't done yet. I normally just use code that I've gotten somewhere and somebody else has designed it from scratch. But in order to be a good programmer and in order to win competitions, I think you actually have to learn how to design software from scratch, because I just think that's the only way you're going to win a competition is if you're actually a good programmer and you can program things from scratch. So now what we wanted to do is we wanted to check our RMS, mean squared error, and our mean squared error is 24,000. On Jason Brownlee's model, he was using a different methodology, and his mean squared error was around 17,000. So his error was less than the error for linear regression. So we create a data set with our actual values and compare them to the predicted values. So you can see that the predicted values are less than the actual values. And then what we do is we graph out our y-pred and our y-val. So you can see how the y-val, you can see the y-val is in amber, and you can see the y-pred is a straight line, and the reason why the y-pred is a straight line is because we're using linear regression, and linear regression is a straight line. So now what we do is we put the output onto a data frame for a month in sales, so you can see we've got the last 4 months, because I like to use for my test training set to be as big as possible, and I only use like 10% of the train data set for my validation. So you can see this is the four predictions that I got for the last 4 months of the time series. And then what we've done is we put that into a data frame, and then if it was a competition, which it's not, then you would have been able to submit the data to the company that you were doing the competition for, which it's not a competition. It's just a really old data set, and it's really small. So that completes our time series analysis using linear regression on the shampoo data set. If you like this video, please like, subscribe, and share. If you want to keep receiving my videos, then please press the notification button by the subscribe button. And what that will do is once you press the notification button, what that will do is that will notify you whenever I have made a video, so you'll keep receiving the videos. If you like the work I do and you want to support me, I've got my PayPal account email address in the description box down below, and the reason why is because I don't get enough subscribers to monetize, so I have to ask for donations if I want to make any money on this channel. So thank you so much for watching this video. I will be doing a blog post on this, and then when I've done the blog post, in the blog post I will give you the link to the code for this video. So if you want to get the code, then you'll need to read the blog post. And that concludes this video. And thank you so much again for watching the video. And I look forward to making more videos for you in the future.